We are all familiar nowadays with the very much ubiquitous LED lamps, pretty much like this one. And this is really a no-name brand. Okay, it says D-LED as a brand, but it's pretty much a no-name. Now, I bought these off eBay, and unfortunately it broke down. It broke down simply because at first it started to flicker, and then at a certain stage it stopped altogether working. And well, not too long ago I got exactly the same problem with another of my LED spots, and as you can see, it's the same size. Now, I unmounted one of these just to have a look inside, and I learned a few things from unmounting it. Okay, well, the first thing you should know is that this is a what you could call a high power LED spot. It has 5 LEDs, and supposedly it gives about 15 watts of, or rather it consumes about 15 watts of power, but they say it gives off about the equivalent luminosity as a 75 watt light bulb. Anyway, these bulbs, although relatively, well, I wouldn't say cheap, but not too costly, if they break down after only a few months, that really upsets me, because normally a light bulb should at least last for a few months at least. Well, actually a couple of years would be the minimum. But, well, it seems this one didn't and the other one didn't either. So I decided to start by having a look inside. Now, it's a GU10 spotlight, which means that it's not a classical E14 fitting, but it's rather with 2 pins that slide in a special connector. So this spotlight also first started to flicker, and then it got so dim that you could say it virtually switched off. So what did I do? Well, I unmounted one. And how to do that? Well, that's quite simple. You gently but firmly unscrew this ring at the top. Okay, so let's see if I can give you a little bit more light. So you gently unscrew this top ring. So you firmly grab it between 2 fingers like this, and you hold the body, the cooling body of the spot between your other hand's fingers. And then you firmly counterclockwise turn like this. You have to give it a few turns, you know. So here we go. Okay, don't lose this. We'll need it again later on. Okay, the next thing you have to unmount is this cover top here, which is actually just clear plastic. So you simply lift it off, or you pop it out like this. There you go. Okay, so you just lift it out. So keep this part clean. You'll need it. You need it later on. Okay. So, and now what we see on the inside are the actual LEDs that give us light. Now, in this one, at first glance, it isn't too clear which one broke down, but I would hazard to say it's the center LED that broke down, and maybe even the one on top. So this one over there. So this one and the center one. I'm not sure, but we'll see in a moment. Now, of course, I unmounted the other one, so I'll show you how it looks like when it's totally unmounted. So this is the actual cooling body, which you see on the still fully mounted one. Okay, and I think it's cast aluminium, although I'm not sure. It could be milled aluminum, but it is aluminum, and there's quite a lot of space inside of it. Okay, and the wires for the LEDs go through that slot you see in the bottom. The white paste you see on top, well, it is a paste, is something like a silicone paste, which allows for better heat transfer. Heat transfer, namely from the back plate, like this, on which the LEDs are mounted. Okay. And then you have the electronic part, which is screwed, or mounted rather, inside the foot of the light bulb. So this is the inside. Now, well, I shouldn't say this is screwed inside the light bulb, but it really screws inside of the cooling body. You can see a thread going all around the narrower opening. And that narrow opening screws on top of the foot of the light bulb. And you see threading here as well. Okay, so this little control block was mounted inside this hollow foot and was stuck to the side of the hollow foot with, I guess, something like silicone. So you can, if you're careful, you can cut it loose. Actually, I didn't cut it. I just took a small screwdriver like this, and I skewered it between the electronic block and the side wall of the foot, and then I jammed it inside the silicone, and that way I broke it loose. Then I proceeded to cut it away, you know, and it gives little pieces like this, which feel rubbery. They don't stick, they are not dirty. This is just dried silicone, and it feels rubbery. Now, the electronics themselves, well, to me they are pretty unclear to read. So I would say that although I'm not quite certain, but I would say that perhaps this part here is a transistor. Let me see if I can give you a close-up. So this part here is maybe a transistor. Could be a thyristor, perhaps. Then you have a small chip, an 8-pin chip right here. And you also have this part here, which looks like an active component. And I think this is a power diode right here, mounted under that small transformer. And then you have a big electrolytic, well, big, that's relative. This is a 4.7 400 volts electrolytic. Let me see if I can show you. Yes, right here. See if I can focus it. There you go. So this is a 4.7 400 volts electrolytic. And of course you have a small transformer here. This is the driver circuit which drives the LEDs, which you see here. 5 pieces of them, and since the spotlight is said to carry or to consume 15 watts, well, that would mean that each LED on its own consumes about 3 watts of power. We'll make a few calculations in a few minutes. Anyway, what this is, I think, is an oscillator which chops up the 220, which comes in through the 2 GU10 pins. It chops it up so that you only get part of the sine wave coming in, and then it sends the chopped waves through a tiny transformer, and once it exits the transformer, it is how do you say, rectified by this power diode here. Now I'm not entirely sure, okay? At this stage this is only pure speculation on my part. Right, so now you had a good look at the insides of such an LED spot, which is all very interesting and all. Our real goal is to find out how to identify the broken ones and the still good ones, because obviously these ones never or rarely break down all at the same time. And so I started to take a rather good look, a rather close look at it. And the way I think you can identify it is by looking at the top of the LED. Now, a good LED should have a uniform cloudy surface like this one. This one is uniform and cloudy. However, if you look at this one here, so let me put a small green fleck on it. So this one here, yeah, and this one here are not cloudy. In fact, they are almost transparent. And if you look with a magnifying glass, I don't know if I can show you with my camera, but I'm going to give it a shot. Okay, so you see the 2 LEDs I marked, and if you look carefully at this LED, or rather, let me see, no, the top one is even clearer. If you look at this one, you see it is partially transparent, so not like this one, which is uniformly yellow, cloudy. But if you look really, really closely, you'll see as if it was, you'd think it was almost cracked inside, and who knows, maybe it is. But you see something like a cracked spot in it, and that is a telltale sign. Now, to be 100% sure, of course, that the LEDs I'm showing you are indeed the ones that are broken, there is a certain way of doing it. Let me show you. If you want to identify the LEDs that are broken, there is a visual inspection method, but there is a far more sure way of identifying them, and that is by hooking up this module by its tiny wires to a variable power supply, which I did. I hooked it up to my variable power supply. Let me show you. Right. So there you have the power supply. Let me switch it on. And what you do actually, once you hook it up to the power supply, is that you slowly turn up the voltage while you watch the LEDs, and that's exactly what we're going to do. So here we go. I'm turning up the voltage. I started at about 1.2 volts. And the trick is you need to turn it up slowly, just about when the LEDs start to flicker on. I mean the still good ones. So I'm going up and up and up and up. Okay, I'm about at 10.4 volts. Now, watch the LEDs as I reach 12 volts. There. I'm at 11.7 volts right now. See? Well, 11.6. And now you can see there are 3 LEDs lighting up slightly, and then the center one is lighting up a tiny little bit, and the top one doesn't light up at all. Right, so I showed you the marks I've made on the LEDs. Well, there they are. I think you can just about see them. I made a green mark on this one. You see it here. And I made a green mark on this one. You see it here. And remember, I identified these 2 LEDs visually. Okay, I didn't use power to test them. I just looked at them closely with a magnifying glass. Right, so I did identify the bad LEDs. Let's move on to the next step. On the print board there are 2 little wires mounted which connect the print board to the power supply driver. Now, what you do before unsoldering the LEDs, which is what we're going to do right now, is you simply push the wires through that hole, up and out like this. Okay, and you make good note of where they were attached. Now, in this case, the LED board has a pink and a white wire, and the pink being the plus and the white wire being the negative. How do I know that? Well, on the print board itself, if you look right there in the corner, let me take a pointer. So if you look right here, you'll see a tiny plus sign. Let me make a close up. Okay, so right here you see a plus sign. So that is the telltale sign which tells you that this wire, this pink wire, is actually the plus. The negative was attached to this point right here opposite the plus pole, which seems logical to do. Okay, so now how do you unsolder it? Well, there aren't 36 ways of going about it. So what I do to start with is I unsolder the tiny wires attached to it. So here we go. There you go. So now I unsoldered the two wires from the LED board. What I need to do now is obviously to unsolder the bad LEDs, which I marked with a alcohol pen. Now this is an SMD board, and that doesn't make things easy, but what I would use to personally to unsolder the bad LEDs is solder wick, something like this. You can buy it on the internet. It's really nothing more than copper mesh, which you heat up above the solder point, and the copper mesh will simply absorb the melting solder. So let's start with a clean bit of copper mesh. So I cut off the bad one like this. So here we go. I put it on top of the LED's connection, and then I heat it up like this. Okay, now I do the other side. Be aware that you shouldn't heat it up for too long continuously, because if you do, well, you might damage the good LEDs, but still. Okay, well, okay, it helped a bit, but not a lot. The LED is still attached. So now I'm going to try to nudge it off the print board by heating it up from the side. Yep, like this. Okay, I heated up its one pin. Now I'm going to heat up the other pin. Come on. Yep, there we go. Okay, this is one of the bad LEDs, and as you can see, it has two pins, two opposite pins, and the plus of the LED is identified by one of the pins, and now I have to take a close look to tell you which pin is positive and which isn't. It's kind of hard to tell. Hang on. Okay, well, I would hazard to say that the plus of the LED is indicated by a small opening in its pin. So right here there is a tiny opening in the pin, and that doesn't indicate the plus, it indicates the minus, the cathode of the LED. Okay, and I guess indeed that would be the cathode. I'll look it up to be certain, but that seems to be the telltale sign for the cathode of the LED. Well, I'm going to proceed now to unsolder the other bad one in the center, And I'm going to do the same thing with the other one I haven't unmounted yet. And then when I'm all set and ready, we'll mount back the good ones onto the bad board. I unmounted the LED board out of the other spot. This is how it looks like when it's still with its electronics in the foot. I think you can just about see inside. You see, the electronics block is stuck to the side of the foot with a glob of, well, silicone paste, and it can be detached quite easily. In construction it looks quite similar to the other one, so I wouldn't be astonished if the producer used the same parts for this LED spot as he did for the other. Anyway, this is the LED board from the other spot. Can you identify which LED is bad? I'll give you a few seconds to think. Watch the LEDs closely. Can you tell which LED is the bad one? Yep, it's the center one. The center one is bad. Now, I checked it visually, of course, but let's check it electrically. There you go. You see? It's the center one. And, well, I have to admit, this one here, well, let me switch on the light. So, this one here is a bit weak as well, so I won't be using this one either. But the center one is definitely the bad one. Alright, so now let's move on and unsolder two of the good ones. Right. Now, I think I can guess, or I can hazard a guess, why the LEDs failed that I unmounted, you know, these two. And the reason is that the amount of conductive paste they put on the back of the LEDs is really not very much. Yeah? And since the LEDs depend on heat dissipation through this backplate and then this backplate through the cooling body, you better provide for sufficient thermal transfer between all those parts. Now, if you look at the ones I unmounted, they have, well, practically no conductive paste whatsoever at their back. Actually, I would say they have none. No. Not these two, and not this one either. Okay, so yeah, well, the reason why these LEDs fail at a certain point is simply because they overheat. The heat transfer is too little. And eventually they burn through. So what I'm going to do is I'm going to use a little bit of heat paste like this, put it at the back of the LED, then solder it back to the back plate, and then when I'm done with that, we'll test the back plate with its wiring and then put extra heat conductive paste onto its back before we place it back in the cooling body. Okay, here we go. The heat conductive paste I'm using has a kind of yellowish gold or bronze color. The color of the paste is really not very important. What is important is that you put enough of the paste on the back, but really on the back of the LEDs you don't need that much paste. So I'm going to scrape off a little bit of it to put it on the other LED, which I'm going to use for replacing. I'm going to choose the nicest LED I found. Okay, this one will do. So you just put a good dollop, but not too much, on the back of the LED, like this. And then you place the LED back onto its back plate, but while looking that you place it correctly, so with oriented in the correct way. So let me see. I mean orientated in the correct way. Let me identify the negative pin. The negative pin has a tiny little slot. Well, had a tiny slot. Okay, this model doesn't have a tiny slot, but it has a dimple, which indicates the negative side. I would say a cutout, maybe, or a dimple. Yeah, well, you see, these LEDs, they differ from producer to producer. Anyway, just always try to identify the anode and the cathode, because if you're wrong, you will destroy the LED, of course. If you bend the pins a little bit, you can straighten them out, but be careful or you'll break them off. So use a needle nose plier like I'm doing and bend them straight. So these pins here should be at a right angle with the side of the LED. Okay, so, and if you look at it from the side like this, the pin should be almost flat and flush with the back of the LED. Okay, so how I mounted, well, I identified the negative pin, looking for a tiny dimple somewhere. Okay, now I place it back onto the plate, and to do that I use tweezers because my fingers are a bit too large. So the LED has two flat sides, one here above this pin and another one here. So I place the tweezers like this over the LED, like this. Then I place it on top of its mounting plate like that. Remember, at the back of the LED I placed a little bit of heat conductive paste. Right, now remember, this is also SMD, so surface mount, so you don't need a huge amount of solder to solder the LEDs. Alright, so in fact the solder which still remains on the pins when I unsoldered them should be enough. So here we go. That's it, that's one side. Now I place my finger on top of the LED and I heat up the pin which is left over, like this, and I press down on the LED. The reason why I do that is to be certain that the LED makes good contact, and in fact it doesn't. Okay, so hang on, I need to correct a little bit. Okay, right, Now it does. Okay. Well, I mounted back two of the LEDs, two of the three good ones I recuperated. Now I'm going to hook up the tiny little power wires to the board, and then I'm going to hook it up to my power supply and see whether I made a good repair or not. One little detail which is important. Now, while I was demonstrating to you how to unsolder the LEDs and how to resolder it to the back plate, you'll notice that I wasn't quite certain how to show you what is the minus and what is the positive on these LEDs. And I'll tell you why. Normally, they say you should look for a notch. On a square power LED, you would see a notch. So it would be, one corner would be cut away on a square power LED. But obviously, this is a roundish one, and so it doesn't have a notch or a squared corner or whatever. So it's kind of hard to tell which part of it is the plus and which is the minus, or the cathode or the anode. So my advice is don't only look at the shape of the LED and try to look for a notch or a dimple or whatever to indicate the cathode or the anode of the LED. Either look the LED up on the internet if you can find the type number. If you don't, then the other way is to look at the plate to which it was mounted and then see whether it was mounted to the minus or the plus. And here on this plate you can see this white lead here, which is the negative, and this LED, which is bad by the way, is mounted with its negative to the negative lead. And that is how I succeeded in identifying which side is negative, because if I look at the pins more closely, yeah, I see on the top side of this LED right here, this little piece here, I see a minus symbol which was pressed into the metal of the lead here. So it's kind of hard to see, but I'll try to make a close-up so you can look for yourselves. So on top of this little metal plate here, so here, there on this metal piece, there is a dimpled minus symbol. It's very hard to see, but once you recognize it on this one, once you see it on one LED, you can see it on all the others, provided of course the producer, the builder of these LED boards uses the same type for all the LEDs, which is never a guarantee, of course. But I was lucky. All the LEDs were marked with a small dimple in the leg of the LED. Now, also the print board has little minus symbols printed, or rather this one has one large minus symbol printed. You see the circle which represents the LED, and underneath you see a long black line. And if you look at the LEDs, you'll notice that the dimpled contact is attached to the side with the long black line. So that too is a sure sign this is the cathode. Right, I hooked up the LEDs to my power supply, and it's still set at about 12 volts. So let me turn down the voltage first. Okay, here we go. Watch the LED plate. I'll announce the voltages. So now we're about 3 volts, 6 volts, 8 volts, 9, 11, 12.2 volts. Well, I would say that my repair worked out fine. I mounted the LEDs back the way they should, and they don't flicker, they don't look broken or cracked, so I think they will work properly. So let's mount them back now into their original housing. Remember, the problem I think was that the LED backplate, or rather the LEDs themselves and the backplate, didn't manage to evacuate sufficient heat to the cooling body, which is this. So what I'm going to do is I'm going to put a good dollop of paste, of heat conductive paste, like this, on top of the cooling plate, and then I'm going to spread it out evenly over the center, like this. Now remember, I'm only spreading it out over the center of the cooling plate. Why? Well, because when I will mount back the cooling plate in the cooling body, the paste will flow out to the sides. And okay, let's not be stingy, let's add a little bit more cooling paste, but just a little bit, like this. Voila. Okie dokie. Right, so now I put the wiring back through the holes of the cooling plate, like this. And I thread them through the hole, okay, from the top. So I put them right here, I push them through, and then I pull them through on the other side, like this. Right, now we put the wiring through the top of the cooling body. Here we go. Okay, and make sure you don't stick any cooling paste on the rest of the cooling body, because, well, that would be a waste of cooling paste, and it would make it all very dirty. Okay, here we go. We're almost there. Okie dokie. There you go. Make sure the wiring doesn't hamper the cooling plate, okay? so that it makes good contact with the back, the top, I should say, of the cooling body itself. Voila, mounted back. Right? So now I must solder it back to the power supply, or the driver, the LED driver, which is what I'm going to do next. Okay, I hooked up my reassembled, or well, at least partially reassembled LED spot to its leg, or to its foot. To test it, I hooked it up to the variac. Now, I'm not going to turn up the variac very slowly, but I am going to turn it up slowly just to be on the safe side, to keep things under control. So if I start to see smoke or sparks flying, then I know there's something wrong. Also, I oriented the spot away from the camera because I really don't want to damage the camera's CCD, or charge coupled device. Okay, well, just watch the area here. We'll see if it works or not. So here we go. Turning up the variac now. Hey, hey, hey! Okay. Yep, we're at 235 volts. Well, I would say that was a successful repair. So let's mount the LED spot back to its original shape and have a final look. To reassemble the spot is really quite easy. What you do, of course, is you resolder the power wires, or the power supply wires, to the driver. Now, how do I identify which one is the plus and which one is the minus? Well, if you look closely at the power supply board, and let me see if I can give you a close-up, you will notice on the board there's a tiny plus sign marked. Let me see if I can show you, because my eyes aren't that sharp any longer. Okay, right there, right down there below, right there, you see V plus, and on the other side is marked the same thing, so V minus, in other words. So look for the V plus for the plus of the power supply, and V minus for the minus. Right. So now, how do you reassemble it? Well, quite easily. You put this part onto the bottom of the cooling body, like this, and you keep your finger pressed on the LEDs here. Okay, so you screw that on like this, and you screw it on clockwise, gently. No need to put a lot of force on it. Okay, hang on, let me just check the wiring is holding. Yes, it is. Okay, so here we go. Okay, and then you give it a good twist to be sure it's locked in place. Then you put the translucent plastic body, the lenses in fact, on top of the lenses, the LEDs I mean. So, and you try to orient the lens in function of the LED. So let's see, like this. Right. Okay, when it's nicely centered, the lens, you take the lens locking ring, you put it on top gently, and then you screw it back clockwise. It takes a little bit of handiness, this, because you shouldn't damage the threading, because it's quite a delicate part actually, this locking ring. Okay, hang on. I'm checking whether yes, there we go. Okay, then you take the body in your hand like this, and then you twist the locking ring until it's tightly locked. But don't exaggerate, okay? So just make sure it's locked in place like that. Alright? Right, so let's give the LED spot a final test. Right, let's put the repaired LED spot through its paces a final time, just to see whether we did indeed make a successful repair and perform a successful reassembly. Here we go, watch the birdie. Well, I would say that's a successful repair. And that is how you repair a broken LED spot.